Okay, let's have a look at this next one. This is how to find turning points. Well, in the last video we looked at, we were finding the gradient at a certain point. And if we've got something like a parabola, well, then the gradient is constantly changing. The nice thing about a parabola is the turning point has only one gradient, and it's always the same. And that gradient is 0. So let's have a look at a parabola, and let's just make something up. So let's say it's going to be something nice and simple. Y is equal to x squared plus 4x plus 4. All right, so first of all, I'm going to just draw this, and I can actually, as I say, there's lots of ways of finding the turning point, and I'm going to use, well, algebra to find it first of all. So I'm going to draw this thing up first of all. So let's first of all make y equal to 0, and when y equals 0, saying, well, if y is 0, what's x? So I'm going to factorize this, and I'm going to have some sort of an x and some sort of an x, and factors of 4 are going to be 2 and 2. So 2 times 2 is 4, so the signs are going to be the same, and they're both going to be, sorry, the signs are the same, and they're both going to be plus. There they are. So it's going to be 2 and 2. Nice and simple. So this is a perfect square. So we've got, so we could say x plus 2, therefore x plus 2 is equal to 0. Therefore, x is equal to negative 2. So what we're going to end up with is something that looks like this. We're going to have negative 2 there. I'm just going to write negative 2 there. And we're going to have a y-intercept. Well, the y-intercept is going to be 4. And we know it's going to be 4 because while if I made y equal to 0, I find x. If I made x equal to 0, I would find y. And y is whatever's left. So y is equal to 0 squared plus 4 times 0 plus 4. So y is going to equal 4. So here it is. Here's my y. And here is my 4. So here is the parabola. I'll try and draw it as best I can. Sorry, you couldn't see me drawing that, but I gave it a shot. I didn't do it out very well, though. Yeah, so there it is. There is my graph. Here's my x. Here's my 0 point. Here's my origin. All right, so we can see the turning point is going to be at negative 2. Well, the question is, although we can prove it with algebra, and it's quite simple when we're using a parabola, because parabolas, of course, have the advantage of being symmetrical around a certain point. But if we were doing a cubic, for example, cubics are not symmetrical around a certain point, usually. So it makes it difficult to actually predict. If I've got, for example, something that looks like this, we know that if we knew this point here and we knew this point here, if this was a parabola, that bit there was a parabola, you could say, well, this is halfway between. And therefore, this would be the halfway point. But of course, in a cubic, it's almost certainly not going to be symmetrical around that point. There are cases when it is, but the majority are not. So let's have a look at how we can use an equation that works for finding the turning point of a parabola and the turning point of a cubic. Now, of course, cubic has more than one turning point. A parabola only has one turning point. Let's find an equation that will work for both. And how we do that? We simply find the gradient function of whatever it is we're looking at. So let's find the gradient function of this here. Now we've already found this, by the way, and the reason we found it is we can know when we're correct. Because if we get negative 2 as the turning point for this particular function, then we know we've got it right. So let's have a look at it. So I'm going to restate the problem. So I'm going to say y is equal to x squared plus 4x plus 4. I'm going to differentiate that, so I've got the gradient function. Here it is, dy dx is equal to 2x plus 4. Now, by now, you would have got pretty good at doing these, so I'm not going to explain how you reduce the power by 1 and multiply the power with all that sort of stuff, yeah? Okay, so here it is. This is our m value now. Now, of course, if it's a parabola, it's going to only have one point. If it's a cubic, it's going to have multiple points, and we'll come to that in a second. So here we have our gradient function. And of course, the gradient is changing all the time here. So here the gradient's like this. Here the gradient's a bit steeper. Here the gradient's even steeper still. But at this point here, the gradient is 0. So we want to find what will the value here be when the gradient is 0. And we know what the value is. We've already calculated it. But let's prove it using calculus, because no doubt it will say, find the turning points using calculus. So let's have a go at doing that. So we know the gradient is 0. Well, this bit here is the gradient. So I'm just going to make the m value, here it is, 0 is equal to 2x plus 4. So now let's make x the subject. So I'm going to say 2x is equal to negative 4. What have I done? I've just subtracted 4 from both sides, by the way, and I've turned the whole thing around. So I'm going to divide both sides by 2. So x is going to be 2 goes into negative 4, negative 2 times. So we've now found the x value of the turning point. Now, this is not where we end. This is just the beginning of the answer. Now what we've got to do is we've got to find the y value, because we're not finding the gradient, the x value, we're finding the turning point or points. That's meant to be a PT, by the way. Yeah, abbreviation for points, yes? All right, so we've got an x value. So now let's put this back into the original equation. Notice the original equation, this equation here, yeah? So here it is. So I'm going to rewrite this over here. So y is equal to x squared plus 4x plus 4. And I'm now going to place the negative x equals negative 2 for every time I see an x value. There it is there. So that's what I'm going to do. And by doing that, the y value will pop out and I'll have a coordinate. I'll have my ordered pair. So let's do that. So y, and by the way, we already know what it's going to be, right? Because this is negative 2 along, but it's 0 up. So it must be negative 2 comma 0. Let's see if that works out here. So I'm going to say y is equal to, well, negative 2 squared plus 4 times negative 2 plus 4. Well, let's have a look at what that comes to. So negative 2 squared is going to be 4 plus, well, 4 times negative 2 is negative 8 plus 4. Well, 4 and 4 is 8, and a minus 8 comes to 0. So therefore we can say, therefore, and I'll write over here, therefore, turning point of y equals x squared plus 4x plus 4 is negative 2 comma 0. Notice we write it not as a separate x and a y value, but we write it as an ordered pair. Yeah? So remember that term, ordered pair. In other words, that's what we mean when we say coordinates, yeah? But we use the term ordered pair. And that's how we find the turning point of an equation.